Alright, for review 3.3, I'm going to go through the first six kind of in detail, and then on the next video, I'm going to burn through the rest of the ones on this page real quick. So this one's going to be a little bit longer than the others. But again, whenever we do reducing radicals, it's good to remember, oh yes, we've got our perfect square. So real quick along the top, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, over 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is the dirty one, 14 times 14 is the kinky one, and 15 times 15 is 225. You probably won't need that for this exercise, but hey, it's up there nonetheless. So these are the perfect squares. So whenever we're reducing a radical, you want to divide by one of these 15 or so perfect squares so that you can reduce and take the square root of it. Alright, so you're going to come across really two different types. You're going to be adding or subtracting, or you're going to be multiplying. When you're adding or subtracting, it's like adding or subtracting like terms. For example, if you were going to do 2x plus 4x, because these both have an x, we can combine those to equal 6 x's. All right? This is the same type idea. If I am, let's erase that real quick. With your radicals, we want to be making sure we are adding or subtracting the same type of radical. So for number 1, these are both the square root of 3, which means I can add the coefficients out front. Alright, so 8 minus 6 is 2. This is simply 2 on the square root of 3. And that's my answer. Now, if I could reduce the square root of 3, I would. But I can't, so we're going to stop right there. Pause the video and try number 2 real fast. Alright, number 2, same idea. We have the same square root for both of these. They're both the square root of 5. So, negative 4 plus 4 is negative 5. So we have negative 5 on the square root of 5. Alright. And since I cannot reduce the square root of 5, that is going to be my final answer. Alright? So whenever adding and subtracting, you got to make sure you have like terms. The square roots have to be the same. Alright? Number 3, whenever we are multiplying, we multiply the radical together and the radicals together, so 7 times 7, and we multiply the coefficients together, 3 times 2. Alright, so here we go. 3 times 2 is 6. 7 times 7 is 49, so that's the square root of 49. Alright. We can reduce the square root of 49. That's one of our perfect squares. If you recall, it is right up here. It's our perfect square. Square root of 49 is 7. So that equals 6 times 7, which is 42. So the answer to 3 on the square root of 7 times 2 on the square root of 7 is simply 42. Alright. Number 4. Number 4 is a bit of a trick question. It's trying to get you to understand is, do you know that square roots and squares are opposite of each other? They basically cancel each other out. Like if I add 2 and I subtract 2, they've canceled each other out. Or if I multiply by 2 and divide by 2, they cancel each other out. Well, in this case, if I am square rooting and squaring, they cancel each other out. So the answer is simply 6. I guarantee you that's going to come up on the test. Alright? But you got to understand those are opposites, so it's just 6. Number 5. Number 5, we're multiplying, so we do it just like number 3. Okay, multiply the coefficients out front and multiply the items that are inside the radicals. So out front we've got negative 3 times 1. Don't forget that's a 1 in there. So negative 3 times 1 is negative 3. And then we multiply the insides. 3 times 18, which is 3 times 8 is 24, so that's 54. So negative 1 on the square root of 50, negative 3, I'm sorry. I'm not sure where the 1 came from. Negative 3 on the square root of 54, because 3 times 1, negative 3 times 1 is negative 3. All right, and from here, you just reduce the radicals. 54 is divisible by 9 times 6. The square root of 9 is 3, so it's negative 3 times that 9 becomes a positive 3 on the square root of 6. And then combine those two out front. Negative 3 times 3 is negative 9, so negative 9 times the square root of 6. All right, so again, multiply your coefficients out front, multiply the items inside the radicals, and reduce if you can. All right. Last but not least on this video is number 6. Again, this time we're subtracting, we're not adding, but same idea. Remember, we have to have like terms. We do not currently have like terms. So what I'm going to do is I'm going to reduce, just in case you do get like terms. So in this case, 24 is, the perfect square that goes into 24 is 4 times 6. And there's no perfect square that goes into 6, so I'm just going to drag that part down. All right. Square root of 4 is 2 times the 2 out front. Square root of 4 is 2 times the 2 out front, so that becomes 2 times negative 2 is negative 4 on the square root of 6 minus 3 on the square root of 6. All right. Now we have the same radical, so now we can combine those together. So negative 4 minus 3 is negative 7. Square root of 6 is negative 7 times the square root of 6. All right, so just because they start off not having the same radical does not mean you can't reduce it and they don't combine. All right, here we go.